Hello, welcome to our first exploration of the assignments for SCP-140. This is your first week of class, so everything might seem a little bit new. This might be the first time you're ever taking an asynchronous online course. It's going to take some getting used to. You're going to have to be in charge of your own learning, your own schedule. You're going to need to take responsibility for all of the work that you do. And I'll be there to help you. You can always contact me by hitting the contact your instructor button or sending a text to the text message phone number that's in the syllabus, or just contacting me using the My LaGuardia function. But in any case, you should be getting started now on learning some things about astronomy. And I wanted to show you how you might go about using the Blackboard site to find the things that you'll need week by week, to set up your own learning environment, your own pace, and to become successful in this class and learn a lot about astronomy. So what I'm going to do right now is share my screen and show you what it might look like as you navigate through the Blackboard site, do your work week by week, and submit assignments. So what I'm going to do first of all is sign into Blackboard. So I'll click on Login right here. And depending on how slow the connection is, it might take a while, but there's a number of different classes that are here. And this is the class that you'll be taking with me. This is a SCP-140 online asynchronous. Now, this isn't the version you're going to see. This is the version that I see as I'm trying to set up the class. Let me show you what you'll see. This is what you see when you log in. So right to begin with, you hopefully have already clicked on the start here. That's how you got to this video. But I would like to show you some of the different things that are available for you to work with and how you might navigate around this site. So first of all, if you have any questions about what we're doing in the class, you should check the syllabus. You can click on this syllabus, click on this link, and there is a tremendous amount of information that you will find here in the syllabus. Ways to contact me, things about the class, links to very important things that you might need, resources from the school, perhaps some tutoring advice, interests in technology, anything like this are things that you should find here. Also, how the grading will work, how we'll communicate, all of this is all found on here. So please do read that syllabus carefully. And if you have any questions, contact me. You can see the contact information. There's my email. You can text message or WhatsApp me at that message there, that phone number there. And then you can also contact me during office hours on Zoom, which is the link that's provided there. There's also a nice link here to our course textbook. This is what our course textbook looks like when you click on it online. A lot of students like to use the online version. And if you click on View Online, you'll get a nice view of our textbook that you can use. You can update to new software if you need to. I'm not going to do that right now in the interest of time, but there are links on here. You can save your progress. You can highlight things if you're using this interface either on a tablet or on a laptop or desktop PC. You can also get pretty good views of this on most smartphones, though I recommend if you're going to be reading the electronic version, perhaps you'd want to do this on a bit larger of a device, but that's up to you. You know how you'd like to read the best. Now, some people prefer to read paper copies, and you can print out a version of this if you'd like. If you come here to the main site and you look at this textbook, you could instead download a PDF version. And you don't have to print the entire version. You can just print the chapters you want. Of course, you'd need to use a printing resource. You could use the one at LaGuardia, or if you have your own printer, you could do that. And if you would rather have a print copy yourself, you could order a print copy. and one will be sent to you. Now, they will charge you for that service, but it won't be the same price as a regular textbook. You can see here that if I order a personal copy like this, and I click on this link, they don't have any available, but if I go to other sellers, I think we might be able to find some here. Perhaps not yet. So hopefully they will. What you can do instead of this is there's a previous version that I know is available. It's about $25. For whatever reason, I haven't quite gotten this loaded up here as a version from Amazon. Most students I find are okay with the electronic version, but if you're having problems finding a hardcover version, let me know, and we can try to arrange to get you one as quickly as possible. All right, so that's the textbook, and the first assignments for the class, as you can see from our Start Here page, are that you want to read chapters 1, 2, and 4. Now that's over the next 2 weeks, so you have some time to get through all of those. And unfortunately, I can't divide it up any smaller than that because chapter 4 is really what we're going to get started at almost immediately. Now, if you want to hear my overview of these chapters, there's a video that you can watch here. This is SCP-140, Tour of the Universe, chapters 1, 2, and 4, my overview of these. In order to do the first assignment, the one that's due by the 18th of September, this is the first laboratory investigation. You'll have to know something about chapter 4. And to do that, you can click on this Phases of the Moon to get started. And what will happen when you click on this is you'll get this little notification that you're going to an outside source. That should be fine. You click on Launch, and away we go. It says that laboratory investigation of Phases of the Moon gives you 10 points. It doesn't sound like a lot, but you'll only have about 6 laboratory investigations, and each of them will be worth about this number of points. So this is, you know, a good portion of your grade. The laboratory grade itself is 25% of your grade. This is 1 out of 6 of that. So you can expect that this is going to be worth a few percentage points of your grade, ultimately. We'll talk a little bit about the grade score later if you'd like. But if I click on Start here, you can see that there's some instructions that we're going to be simulating the moon as it orbits around the Earth and the Earth as it rotates over the course of the day. And to do this, we have some really clever software that's going to run. And let's see what this software looks like. Here it is. So when you run this software, you have a lot of information that's being given to you. You have your position on planet Earth. You're standing here and we're looking over the North Pole and we're seeing a person standing on one part of the planet. You also can see the moon. The moon goes around this circle. Now we know it's not exactly a circle, but for this purpose, it's fine for us to think of this as a circle. And the sun is really, really far away from the Earth and the moon. And so we indicate the sunlight coming towards us by these parallel lines. And if you watch the video that I have on chapters 1, 2, and 4, you'll learn a little bit about why it's okay for us to assume that the sunlight is coming in on parallel lines. The other thing that you get is a piece of information about the phase of the moon. So right now, I can see that it's a new moon. I can also see how illuminated the moon is. The moon is 0% illuminated. And the time since a new moon is 0 hours because it's a new moon right now. You can also see down on the lower right, something called a horizon diagram. That's what I imagine I see if I'm standing on planet Earth and I'm looking up into the sky. I'm going to see the sun as high as it possibly can be in the sky. That's because it's noon. And I can tell it's noon because of my position on the planet. The moon is also on this view, but I can't see it because the sun and the moon are very close to each other in the sky. That's actually one of the ways we know it's a new moon. And we can do some other things as well. I can show some different things in the diagram. Like I can show the angle that the moon is making as it moves around in its orbit. one cycle around should be a full 360 degrees, but you'll see that the angle might go from 180 back down to 0. And we'll discuss a little bit why that might be as we look a little bit more carefully at this diagram. If something says you can show a lunar landmark, that might be useful for some things, might not be. I'm not going to turn it on right now. And you can also do something that says show time tick marks. I really like this because it demonstrates to us how the Earth's position is really similar to a clock. Where you're standing on the Earth in comparison to the sun is really what time you see on your clock. Right now, I'm recording this at night. It's after sunset, but before midnight. And so if we were on a planet that didn't have a tilt to its axis, and it was exactly 12 hours of sunlight and 12 hours of darkness, which is what it's at the equator, then I could say that the time would have to be between 6 p.m. when sunset and about midnight when I was on the opposite side of the planet from the sun. Depending on how much time had passed between those two events, I could figure out what hour precisely it was. So your position on the Earth really tells you what time you are. Now, what can you do with this simulation? Well, you can do a lot of very interesting things. One thing you could do is you can change the moon phase to any of these different phases. You may have to investigate what these phases mean in chapter 4. Crescent and gibbous, waxing and waning are really important vocabulary words for you to come across. But let's move to something like waxing gibbous and see what happens. If I stay on my position on the Earth with respect to the sun, it's still noon where I am. But the moon has moved to a different position around the Earth. Now it's actually on the opposite side of the Earth, so it wouldn't be possible for me to see it if it was in this waxing gibbous phase and it was noon. I can move my horizon diagram around and see if I can identify where the moon is. And I think I can if I spin around here. Look, there's where the moon is. You can see the moon is below the horizon, which means I cannot see it. That's pretty interesting. So this horizon diagram is useful if you want to get a sense for where the sun is in the sky and where the moon is in the sky. One thing humans don't often appreciate anymore, because I think we've kind of disconnected ourselves from the sky a little bit too much in our modern world, is that the moon is up above the horizon at least half the time during the day. Now, of course, it's harder to see the moon during the day than it is at night because the sun is so bright. But you've probably, hopefully, maybe gotten the chance to see the moon during the day once in a while. And yes, the moon is sometimes visible during the day, but sometimes it's not. Here's an instance where the moon is not visible during 12 noon, exactly when the sun is highest over our heads. So what's some other things that I could do in this situation? Well, I don't have to stay at this point of the Earth. I can move the Earth around. And as I move the Earth around, I'm really moving myself around this sort of spinning planet like this, spinning it around and around and around. And as I do that, I can see the horizon diagram is changing as I move myself around. Now, you can't do this in real life. I can't move the Earth one way and then the other way in real life. And so this is a kind of a fun thing that I can do as an experiment to see what might happen if I move things around. I can also click on the moon and move it around and see what happens depending on where the moon is. And you can see here that, as I described earlier, we jump between 180 degrees. That's when the moon is exactly opposite the sun. You can see that that means the moon is full. And then I go 180 degrees all the way back down to 0. Those two phases, or two ways the moon is behaving in the sky, are either called the waxing phase or the waning phase. In this case, it's called the waxing phase as it gets over here. And then it's the waning phase as it goes all the way around to the other side. Well, if you start to fool around with things and you've kind of gotten lost, a nice thing to know is you can always click reset. I reset to where I started from. And so if you have confusion or if you have things that aren't working, maybe try clicking on reset. Now, what's something else I can do? As the days and the hours and the weeks and the months and time goes on, things are going to change in the sky. The moon isn't going to be in the same place. And we're also going to experience days pass, sunrise, sunset, and so on. And if you want to see how all of that stuff works together, there's a nice animation that you can start. And if I click on Start Animation, that's what we're going to see. So here we go to sunset, and you can see it's now nighttime. But what has happened is that the moon has slowly moved from its position. It's no longer a new moon. It takes about a month for the moon to make one orbit around the Earth. And in that month, we're going to see different phases. That's exactly what's going on here. I'm seeing different phases of the moon as I'm moving from day to day. Now, I can only see the moon when it's above me in the sky, and I can get a sense for when that's happening by looking at the horizon diagram. I can also get a sense for when that's happening. Let me pause the animation here. By looking at the angle information that I have. The angle information that I have is telling me how far away the moon is from directly overhead. So right now, the angle is said to be 47.9 degrees. If the moon was more than 90 degrees away from overhead, then it would be beneath the horizon and I wouldn't be able to see it. So that can be a really useful thing to know, if I look at that angle, whether I can see the moon or not. But I can also go down here to the horizon diagram and I can see that, oh yeah, the moon is above the horizon right now. That means I can see it in the sky. In this case, it's something called the waxing crescent moon. That means that it isn't fully halfway illuminated yet. It's kind of got that crescent shape and it is waxing, which means that as time is going on, it's getting more and more illuminated. And I can also see that I can see it during the day. The time, if I were to do the time tick marks, is pretty close to noon where I am standing. And that means at noon, if I were to look about 50 degrees away from the sun, thinking of an angle on the sky, I'd be able to see this waxing crescent moon. Really interesting stuff. Well, what if I didn't want to just run the animation kind of as this ongoing continuous rate? What if I wanted to just increment a different amount of time? Like, what if I wanted to pass a minute or two? Could I do that? Well, sure, I can do that. And as I click the minutes, you can see it says on the very bottom beneath the horizon diagram what the observer's local time is. 11:52, 11:53, 11:54. I can click all the way till 12 p.m. That's exactly noon. So if you want to be exact in your timing, it's useful to have these little increments. What if I wanted to move an hour into the future? Well, watch what happens when I click 1 hour. Boom. I move one little tick mark around the Earth as the Earth is turning. 24 of those hours is going to make a day. So let's see what happens as I keep going. 2, 3, 4, 5, 6. 6 is sunset right now. 7, 8, 9, 10, 11, 12. Now I'm at midnight. The moon is below the horizon, as is the sun. And I can do another 12 increments. Here comes sunrise at 6 a.m. And as I keep moving back over here, I'm now back at 12 noon, 1 day later. The moon is slightly more illuminated than it was before because an extra day has passed. And it's still 12 noon because I am exactly at that location on the Earth and I incremented in hours. I could also increment in days. If I increment in days, I won't see that spinning of myself around the planet because I'll come right back to the same location. But I can then easily track what's happening to the moon as it's moving around the Earth. So that's kind of a neat thing that you can do. Now that you have a good sense for what's going on in this simulation, you're going to have to do some experiments and demonstrate that you really understand how all of this works. So the first question that it's going to ask you is to identify angles that are associated with different phases. And you're going to have to go ahead and set all of this up and see which phases are associated with which angles. Note that there could be more than one right answer for the angles. There's sometimes a range of possible angles that can give you these phases. So that's the first question you're going to answer. The second question that you're going to answer is going to tell you that you have a certain amount of time for the moon to cycle through all of its phases, to go from new moon to new moon. So you're going to see how many days and hours it takes until you get to this particular phase. And the phase is waning gibbous, and the moon has to be 77.8% illuminated. Now, there's a lot of different ways you can set up the experiment to answer this question. You could run an animation. You could increment the amount of time. I typically recommend to students to increment the amount of time rather than run the animation, but it's up to you. You can do it any way you want. Always start by resetting at the new moon. And then what I'd like to do is see how long it's going to take for me to reach 77.8% of the moon illuminated, starting from this starting point. You must be careful though, because if you move yourself around the earth by doing something like this, then you haven't started at that starting point, noon at the new moon point, and you'll get the wrong answer. So you've got to be careful that you always start where the question asks you to start. So if you get messed up a little bit, try clicking reset, and then maybe you start the animation. Maybe you find it's going a little too slow, so maybe you speed the animation up to see when you get to this point. I'm tracking the illumination, and let's say I was going for a waxing crescent at about 15% illumination. Maybe I pause here. Oh, I'm a little bit too far. I might have to increment back in time a bit to get to what I'm looking for, maybe 15.1% illumination, or whatever the number happened to be. Each person in the class is going to get a different value. That's way you can work with other people in the class on this, but you will have to figure it out for yourself what your question is actually asking for. What does question number 3 ask? It says, simulate the moon when waxing crescent is reached with 25% illumination. So at this point, you should be an expert in being able to get to that situation. All right, so I'm going to try to do that, something like a waxing crescent with 25% illumination. Not quite there yet, but I'm going to do that. I'll move ahead to 25%, something like this. I'm close, but I want to be a little bit closer if I was going to do this for real. It says, move the observer on the Earth to determine what time to the nearest hour that the moon rises. Well, how do I know when the moon is rising? Well, I could use an angle. And the angle that the moon has to make between me and when it's rising is 90 degrees, right? So right now, the angle is 57 degrees. And is the moon rising or is it setting? That's something I would have to figure out. Well, the moon is rising when it's in the east. And so it's below the horizon. So it hasn't yet risen yet. I'm going to have to move forward in time a bit in order for it to rise. And soon it will be rising. Okay, it's rising fairly soon. Now, unfortunately, my angle right now is no longer the angle I want to make it with where I am located, because now I'm on a different spot on the Earth. That's okay. I definitely want to be able to figure out where I would have to be located in order for the moon to rise, but I think I have a pretty good understanding of that right now. The moon is very close to rising at about this time. I could try to get it closer to exactly the rising point if I look here and then maybe move around some minutes or something like that. Try to get it as close as possible. But again, this is something you're going to want to simulate. If I go to question number 4, I'm asked to reset the simulation, set an observer time, rerun a lunar cycle, and then try to figure out when I reach a particular phase with a particular illumination. This is a little bit of a tricky thing. So let's see if I can explain how this works. There we are. So I'm going to reset the simulation. And it says, adjust the position of the observer without adjusting the moon so that the observer's local time reads 6 p.m. So right now, my local time reads 12 p.m. You might have a different time, but I'm going to adjust the person so that it reads exactly 6 p.m. I know that happens to be right at about sunset. And that's sometimes a little hard to get exactly, but I'll try my best. What you don't want to do is move the moon, so I can't increment the animation. That won't work. I just need to get the person to be as close to 6 p.m. as possible. Sometimes you can get dead on. I just got it dead on. Look at that. So I've done the first part of the instructions. And then I'm going to start running the lunar cycle, making sure not to pass the next one, and observe when I am going to a waxing crescent phase with 16.4% illumination. And then I'm going to have to see what time it is when I get to that point. Right? It's going to be maybe a number of days in the future. I'm not sure. But as I start the animation, I'm just going to make sure I don't move my person around the Earth and then see if I can pause at exactly that time. And that this was what it had asked. Maybe it had asked for 0.5% or 0.7% illumination. I will pause right there and I can see that the observer's local time is 12:48 p.m. So that's what I would have put in if that was what they had asked for. Question number 5 asks me to do something else. It says, start the simulation at a waning crescent phase of 14.6 illumination. And then I'm supposed to increment 29 days. Right? So let me just reset just to make sure everything's working. I'm going to start the simulation at 14.6 illumination. So I could actually move the moon around until I get to 14.6% illumination. It doesn't say I can't do this, so I think this is going to be all right. Can get close enough. There it is, 14.6%. And now I'm going to see what happens 29 days after that. So increment 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Keep going all the way to 29 days. And I'm going to see what phase the moon is at and what percent illuminated it is. So that's going to be something you're going to do, but you're going to have a different set of values. Question number 6. Question number 6 asks me to simulate the waning crescent moon at 3% illumination at local time of 9 p.m. and then see how many hours I have to wait to see a setting moon. Okay. So I have to set all of that up. I need a waning crescent moon at 3% illumination. So maybe if I go an hour in the past, getting close to 3% here. All right, I've got a waning crescent moon at 3% illumination. Adjust the local time to be at 9 p.m. Oh, I've done that already. I happened to just land on that. But if I hadn't been there, I'd have to move myself around planet Earth until I got to 9 p.m. How many hours will I have to wait to observe the moon setting? Well, if I look at where the moon is right now for my simulation, it's on the other side of, which had just set not so many hours ago. So I'm going to have to wait a number of hours, right? 1, 2, 3, 4, 5, 6, 7, 8 hours to get it to rise. And then it has to go all the way around again. Once it's back there towards the western horizon, then I'll know how many hours it was before it could set. Question number 7. It asks what is the phase of the moon that rises at 3 p.m.? You'll just have to figure that one out for yourself. Question number 8 asks, many people are not aware that the moon is visible during the daytime, which is something we've mentioned already. How long is the moon visible during the daylight? Well, I'm sorry, I misread that. It says how long the moon is visible during the daylight depends on what phase it is. How many hours is the waning crescent moon with 6.7% illumination visible when the sun is up, according to the simulation? So you'll have to simulate the moon at such a phase and illumination. And when you do that, so I need the waning crescent moon at 6.7% illuminated. There I am. So it says, simulate this. You're going to have to see how many hours the waning crescent moon is visible while the sun is up. So when is the sun up? Well, I can start, the sun rises at 6 a.m. and I can ask myself the question, is the moon in the sky? Happens to be in this situation. It might not be in your situation. And then I can increment and see how long the moon is up while the sun is in the sky, right? Well, all of a sudden now the moon is setting. So if I increment one more hour, now the moon is no longer in the sky, even though the sun is. So I should be able to figure out how many hours the moon was in the sky at the same time as the sun was in the sky. Question number 9 asks me to, again, simulate the moon at a certain phase in illumination. It says, assume you want to observe the moon at 7 p.m., the local time simulated in the applet, close to overhead. How many days will you have to wait for this to be possible? So let's see how we would do this. I'm going to give a waxing gibbous phase. And one of the interesting things about this question number 9 is that this question looks at what time you're doing the assignment. And it looks at the day, and it actually is figuring out what the proper phase of the moon is. This is actually the phase of the moon right now. It's a waxing gibbous at 94.9% illumination. So this answer to this question is something that will be true for you. This is how many days you'll have to wait to observe the moon directly overhead at whatever time you're given. I'm given 7 p.m. This question was one I came up with because I thought, sometimes people want to know, when can I see the moon? Well, this is a way for you to figure it out. So first you have to simulate the moon as it is. It's a waxing gibbous at 94 point something percent illuminated, 94.9. Let's see if I can get to 94.9. Close. There it is, 94.9%. It's a waxing gibbous. Now for you, when you're doing this assignment, it might be a different phase. I want to observe the moon at 7 p.m. solar time, close to overhead. How many days do I have to wait before this is possible? Okay. So how do I figure this out? Well, the first thing I can do is I can adjust my local time to 7 p.m. As long as I keep the moon at the right phase, that's fine. So let me move the moon, my observer around to the other side of the planet so that it's about 7 p.m. local time. Very close. Oh, almost got it. At 7 p.m. It's okay to be a little bit off. There's some variation that's allowed when you're answering these questions. Can't quite get 7 p.m. 7:01, that's good enough for me. You're only a few minutes off each time. Now, I want to see when the moon is going to be directly overhead. So how do I decide when the moon is directly overhead? Well, I can do something like this and see when the moon crosses, we call the meridian, this imaginary line between north and south. So as I increment my days, I'll see the moon doesn't seem to be getting closer to overhead. But if I keep counting those days, eventually it'll come back around at 7 p.m. And I'm very close now. I haven't been counting the days, but if you have, you would know that it's right about between one of these 2 days. And there's enough room on either side that if you said plus or minus 2 days or so, you'll get the right answer. So that's how you would do this problem. And the very last problem in your first laboratory investigation, problem number 10, says as the month progresses, the amount that the moon is illuminated will change. However, the trend of illumination is not simply a linear growth. That means that as 1 day passes, it's just, and then a second day passes, doesn't mean it's twice as illuminated, right? It actually changes a little bit. Follows a curving path. We're going to try to create this curve. So the way you do this is you look at the time since the new moon and you indicate the percent illumination and you start to fill out this table. This is a way that we collect information. Now you could imagine doing this over the course of a month and taking these notes down in your own notebook, but we have the advantage of our simulator here. So start at a new moon. Maybe we'll reset even. And we're going to say, I want to know what happens after 18 hours. So increment out for 18 hours. So that's 5 hours, 6, 7, 8. And I can also check up here, 8 hours since the new moon. 13, 14, 15, 16, 17, 18 hours. So at this point, I can see it's 0.6% illuminated. There's a percentage indicated here, so I'm going to put 0.6 in here and then submit. And if I get the right answer, it'll give me a little green check mark and it'll plot the little point on a graph down here so I can see what's going to change and what kind of curve I'm going to make, right? Now, you can see that it says different things here as I add more and more points. As I get more and more of these on, I'm going to get closer and closer to that full point. So then the next thing I want to do is 2 days. So let's see, let's do 2 days. I want to go up to 24 hours as a day. And then I'll do 2 days. And now it's at 4.5% illuminated. Great. And you can see now I have a little bit extra what I need for my points tally. And I'm just going to keep doing that, adding more and more points to see what this curve looks like. This is the last question. So this is your first laboratory investigation. It may be a little bit challenging, and if you run into problems with it, please contact me and let me know. All right. So now what I'd like to do is I'd like to show you just one more piece of information regarding your work that you're doing for the class. As you can see here, we've got links to a discussion board post, and I want you to do that as well. The first discussion board post you have is introducing yourself. And there's a prompt that says how to introduce yourself. When you click on Create Thread, you'll read the prompt, what it says to do. Make sure you read that prompt carefully because those are what I'm going to be looking for when I grade your assignment. So write a few paragraphs about yourself, including your major degree, something about your background, places that you've lived, interests and hobbies, and give yourself an image that represents yourself. And you're going to post this, including a subject, and then you're going to reply to at least one other person in the class. Each week, you're going to have a different discussion board post to do. This week, you actually have two. You're going to have this post, and you're also going to have another post that's called 321. You can find all these posts listed under the discussion section. So 321 asks you to name 3, 2, and 1 different things, 3 new things you've learned in this class so far, 2 things you don't understand completely, and 1 question you'd like to have answered. Additionally, there's an open forum where you can post any questions or thoughts that you might have. If you'd like to get in contact with other people in the class, hopefully this can help out. If you have any questions about homework or you want help from other people, maybe you want to start a WhatsApp group to talk with people, you can use all of that. And that's really our first introduction here. I don't want to give you too much to think about, but I wanted to at least show you how to do that first laboratory investigation and introduce you to the discussion boards. Next week, we'll actually start our first problem set. You could, if you're ready, start it yourself. If you click on problem sets, you'll see that it's available. That's kind of working ahead, but it's based on chapters 1, 2, and 4. So if you would like to work ahead, it's ready for you to do that. There are also additional discussion board questions that you can answer. You just have to read what the prompts are and see if you can answer them. And in fact, you can even go one additional week ahead and do the second laboratory investigation. You'll need to read the instructions on how to do that. You might need some help with that. You can contact me, and I'll be doing some videos that explain that as well. So get used to having these videos that help you work through some of this work. And if you have any questions, please do contact me. I'm happy to help. But that's all for now. I hope you enjoy all of your time here in our class, and we'll be interacting with you very shortly. Have a wonderful time.